Hello students, welcome to my channel Capacitor. Dear students, today's topic is a capacitor. Sometimes people ask me that why the name of channel is positron. Very clearly like to tell you, dear students, you know the fundamental part is about. Fundamental part is about, matter is divided into five steps. Solid, liquid, gas, B. Bose-Einstein, condensation and plasma. Whatever be the state of matter, no matters, all of they are made up of molecules. Molecules are further made up of atoms, and atoms are further divided into electron, proton, neutron. Electron, proton, neutron are said to be the fundamental particles. Why fundamental particles? Because they cannot be broken further. If this definition is true, then neutron is undoubtedly not a fundamental particle, because neutron has a lifetime. Within the nucleus, the stability of nucleus depends only on the breaking of neutron. Actually, neutron breaks into proton and electron and other particles becomes. That is not your topic. So, electron, proton, neutron are said to be the fundamental particles because they cannot be broken further. Simply you say. Dear students, till today more than 65 particles have been discovered so far which are said to be the fundamental particles. For example, electron, proton, neutron, they have every fundamental particle have their antiparticle. For example, proton has their reverse particle is an antiproton, and the electron has an antiparticle that is said to be the positron, and neutron has antineutron, and many I can name right now: meson, pi meson, negative meson, neutrino, antineutrino, a lot. More than 65 particles have been discovered so far which are said to be the fundamental particles. So positron is what? Positron is the antiparticle of electron. Right? And so the name of my channel is a positron. Okay, being the teacher professional of physics, so the name of my channel is positron. Dear students, today's topic is capacitor. Actually, since last few days I was not in town, so I couldn't make my videos, but I can promise you right now that regular you will get my videos related to the topics. Dear student, today's topic is a capacitor. What capacitor is? A very little thing I'm telling you, a very basic thing. I'm trying to correlate mechanics, electricity and magnetism all together. Look here. In the mechanics, the kinetic energy is half mv square. The rotational kinetic energy, Kr, you write, half I omega square. In the capacitor, energy is stored, that is UE. U suffix E means capacitor is what? It stores electrical energy, or the energy in electrical form, and that is written as UE equals to half CV square. And the last one, the magnetic energy store, the device used to store the magnetic energy, magnetic coil, no doubt, and that is half Li square. Now, dear students, the four equations are written here. Let's discuss one by one. K is equal to half mv square if a particle having the mass m and velocity v, then its kinetic energy will be half mv square. Even from 6th standard, you are studying this formula. Now, rotational kinetic energy is half I omega square, right? I is a moment of inertia. Now, electrical energy, capacitor is what? Capacitor is a device which stores the maximum energy in minimum area. Actually, it is a technique, it's a technology, it's a method to store the maximum energy in a minimum volume. Now, the stored energy are basically, very simply you can define the capacitor is a device which stores the energy in electrical form, and the electrical energy is a half CV square. Now, coil is a what? That stores the energy in magnetic form, or the magnetic potential energy, and that is equal to half Li square. Now, this is very important that all the formula are similar. They are analogous, they are parallel to each other. M is a mass here, I is a moment of inertia, C is a capacitance, and L is a inductance. Right? This is kg, this is a kilogram into meter square, I is equal to mr square. This is capacitance farad, and this is L inductance. This is Henry, expressed in terms of Henry. Why I have written this? Actually, the students get confused, right, over the formulas. So, all the formulas are similar. There is no difference. You can, if I have to discuss this, how will I explain? Look here. Whatever role is played by the mass, right? I'm telling you the physical interpretation of these formulas. Whatever role is played by mass in linear motion, same role is played by moment of inertia in rotational motion, and same role is played by capacitance in electricity, and same role is played by inductance in magnetism. Or you can say that it is a electrical mass, it is a magnetic mass. This is I is a inertial mass, right? You can say M is a mass, I is a inertial mass, C is a electrical mass, and L is a magnetic mass. So all the formulas are similar, they are analogous to each other. Now, dear students, today's topic is a capacitor. As just I have told you that what the capacitor is. How will you define the capacitor? That capacitor is a device which stores the maximum energy in minimum volume or area, right? It is a technique, it is a method that how maximum energy means how the maximum charge can be accommodated on a plate, or what are the parameters which decide that how much charge a body can be given, right? So, dear students, what I am going to discuss, just a minute please. Now look here, that what I have told you, that capacitor is what? Capacitor, a device which stores maximum charge in minimum area, right? Now, what the method is applied, let's talk about. Before going on the capacitor, let's take. Dear students, actually I have to remove this with using the wet hanky. Now, dear students, before going on the capacitor, some very important topic you have to discuss with me. One is a polar and non-polar molecule. Polar and non-polar molecule. What I have said that before going on the capacitor, the first very important topic I have to discuss with you. What is polar and non-polar molecules, right? You must have studied dipole. Dipole is what? You write like this. This is charge plus Q, this is minus Q, and they are separated by a distance 2L. This 2L is not a big distance. It is in terms of angstrom, we do not write L. Rather, we write 2L. Why? Because in most of time when you are trying to find out the electric field or potential, sometimes you have to take half value. So the half of 2L becomes L and it becomes easy to calculate. That's why we write 2L. But 2L is not a big value. Actually, it is in term of angstrom, 1 angstrom, 1.1, 1.2 angstrom, like so on. Now, dear students, you write electric dipole in this way. The two charges plus q and minus q separated by a distance 2L. Right? Now look here, dear student, the two charges. How will you define the electric dipole? Electric dipole is a system which consists two charges equal in magnitude, opposite in nature, separated by a little distance. Electric dipole is a what? It consists two charges equal in magnitude, opposite in nature and separated by a little distance. And the electric dipole moment, you write electric dipole moment. How do you write? Look here, electric dipole moment P is equal to one charge multiplied by the distance between Q into 2L. And the unit is what? Q is a coulomb, 2L is a meter. If the unit of L is a meter, then unit of 2L is also meter. Now, dear student, if you write the dimension, then coulomb is a 80 and this is 80L. It was basically I was discussing. This is not a matter of today. This is not a topic of today actually, but I have to discuss with you all. Now look here. Dear students, what I have said, that actually when you are studying the capacitor, you have to study the dielectric. And dielectric, if you have to study dielectric, then you have to study the polar and non-polar molecules. Dear students, polar and non-polar molecule, like let's talk about the homogeneous molecule. Homogeneous means that they are consisting the atoms of same type. For example, O2, N2, right? In oxygen has, that is 16O32. Then its electronic configuration is 286. Last one, the last orbit is consisting 6 electrons, so it requires 2 electrons to get its octet complete. So what happens? It shares 2 electrons with the neighboring oxygen. So O and O, they share 2 electrons each, and so O and O are connected by a double bond. Dear students, this has 6. Here is a 2 electron, here is a 2 electron, 2, this. It's a 2 electron, they are in share. Actually, when there is a homogeneous atom, the electrons are shared by same type of atom. Then the shared electron lies just at the mid, right? The shared electron lies just at the mid of the bond. That is why no one gets polarity, either this oxygen or this oxygen. No one gets the polarity. Such a molecule is said to be the non-polar molecule. Non-polar molecules means because of sharing, the shared electron lies just at the mid of the bond. That is why no one gets polarity, and that is why such one is called to be the non-polar molecule. But let's talk about the H2O, which is a very important polar molecule. That is why I am taking this example. Again, you said, dear student, what you said, that oxygen has 6 electrons in their outermost orbit. So it is 2, this is 2, this is 2. Now, this is hydrogen has 1 electron. Yeah. Now, this 1 electron of oxygen will share 1 electron with this hydrogen, and another 1 electron will share with this one. So 1, 2, 3, 4, 5, 6, 7, 8. It has got the octet in third orbit. Third is the last orbit here, but hydrogen has only one orbit, and first orbit becomes stable with the 2 electrons. So it has got the 2 electrons. But now look here, dear students, what happened? Actually, these are heterogeneous, right? Oxygen and hydrogen are different atoms. Such a molecule is said to be the heterogeneous. It means the electron is shared between the different atoms. Now, in this case, shared electron undoubtedly will not exist at the mid of the bond. Rather, the shared electron will be attracted, will go towards more electronegative. If you will compare, you all are the students of chemistry, I am very sure and damn confident that you know this very fact that between the hydrogen and oxygen, undoubtedly oxygen is a more electronegative in compared to the hydrogen. That's why the shared electron will be attracted by the oxygen, and shared electron a bit shifts towards the oxygen because electrons in a negative charge, it is going closer towards oxygen. That's why it will becomes del minus, and that it will become the del plus, and it is a permanent polarity. Again, in the same case, you can say, now what do you say, that electric dipole is a what? That is the two charges having equal magnitude, opposite in nature, and separated by a little distance is said to be the electric dipole, and electric dipole moment works out to be the one charge multiplied by the distance between them, and it is a permanent polarity, right? It cannot be abolished, it cannot be removed at all. Now, dear students, look here, very interesting, I'm telling you. We are discussing about the two kind of molecules. One is a polar and there is a non-polar molecule. What is the impact of external electric field? What is the impact when external electric field is applied either to the polar or non-polar molecules? No matter, right? What is the impact of external electric field on polar or non-polar molecule? I have to discuss with you all. Dear student, in the polar molecule, they have permanent polarity. If you do not apply, and one thing also I have to tell you, this is a minus q, this is a plus q, right? And this is the distance between the two charges here. Electric dipole moment, you say one charge multiplied by the distance between the two charges. Dear students, very important fact that the direction of electric dipole moment is from negative to positive, right? Always keep in your mind the direction of electric dipole moment is from negative charge to positive charge. Electric dipole moment is a, dear student, electric dipole moment is a vector quantity which has the direction from negative charge to the positive charge. So electric dipole moment you express in this way. Now what I am trying to tell you, dear student, in the non-polar molecule, there is no polarity at all. In the polar molecule, there is a polarity, there is a permanent dipole moment. Now whether it is a polar, let's talk about the polar. In non-polar molecule, there is no polarity at all, right? But in the polar molecule, what happens if you do not apply the external electric field? Then the dipoles will be distributed like this, right? Their distribution is a random. Their total impact is zero. What I have said, that if you do not apply the external electric field, in the absence of electric field, what to say of polar molecule, non-polar molecule? Non-polar molecule do not have any polarity, so I am not talking about that. But even in the case of polar molecules, there, in the absence of electric field, their dipole moment is distributed randomly and their total impact is zero. It means in the absence of electric field, yet every individual dipole has a every individual molecule has a permanent dipole moment. Even then, their net dipole moment will be zero, because in the absence of electric field, these dipoles are distributed randomly. But in the presence of electric field, what happens, if a dipole is kept in an external electric field, then there is a torque acting. In my in just a few weeks ago, I made this video. If a dipole is kept in an external electric field, then a torque be used to act, and that torque is a tau is equal to P cross E, or you can say Pe sin theta. And the impact of this torque is a what on the dipole? This torque tries to align the dipole along the direction of electric field. What is the impact of what I have said? That in the case of non-polar molecule, they have permanent polarity, they are permanent dipole, but even in the absence of electric field, they are distributed randomly, their total impact is zero. But as soon as the electric field is applied, these dipole tries to align themselves in the direction of the field. And why they align themselves? Because when a dipole is kept in an external field, a torque begin to act on the dipole, and that torque is tau is equal to P sin theta. And what happens now? Dear students, because of this torque, dipoles will align along the direction of the field, right? And it is said that the plate has your dielectric, which is consisting non-polar molecule, will be highly polarized, right? You will say, means when the dipole align themselves along the direction of electric field, it means that your dipole has been polarized, your material has been polarized. Dear students, again I am telling you the fact that the direction of electric field is from positive charge to negative charge, and the direction of dipole moment exists from negative charge to positive charge. If you are studying the physics, undoubtedly you should know about the directions, you know about the vectors, a lot of. Let's start further. This that is us talking about the polar and non-polar molecule. Now we have to talk about the dielectric. What happens? Look here. Dielectric is what? Dielectric might be made of polar or non-polar molecule, but it is the insulator. Basically, it is the insulator, right? Mica, the paper pieces. These all are the dielectrics. Look here. It is a positive plate, right? And this is the negative plate. What it means of this plate? Plate always doesn't mean the capacitor. Plate means you are applying the electric field. What it means of these plates? I have considered the two plates. One is a positive and the is a negative. It means I have applied the electric field. Now, dear student, just I have told you that in the case of non-polar molecule, in the absence of electric field, these molecules would have been distributed. These molecules, these dipoles are randomly distributed, but in the presence of electric field, what happens? Look here. Consider one, just I am considering two dipoles in this field. Only two lines of dipole. What I have taken, the two lines of dipole in the presence of external electric field. What happens? Look here. Dipole has positive and negative charge. This positive charge will attract the negative charge of dipole, so automatically this one will be positive. In the similar way, this negative charge will attract the positive one, so negative will be here. Now dear students, this very bracket is consisting positive charge here and negative charge here, and approximately you can say that these positive and negative charges will be cancelled, and what is left here? Look here, here will be left negative charge. It is not only actually the two dipole, there will be series of dipoles. The two dipole I have considered, the two lines of dipole I have considered for the convenience. Now look here, so what happens? The inner charges will actually make each other ineffective or will cancel the impact of each other. So here left negative charge and here left positive charge. Now look here, applied field is because of this, and this is from positive to negative. E suffix A means applied electric field. I'm representing the representation I'm giving my own, right? Now look here, this is the, here is negative charge left, here is a positive charge left, and this will be called, this one electric field because of dipoles will be called induced electric field, and the induced electric field EI is this. Now look here, the applied electric field is that much in this direction, and the induced electric field is oppositely directed, and so net electric field will be what? That is, induced field will be subtracted from the applied field, right? The net field will be what? The induced field will be subtracted from the applied field. It means the impact of dipole is what? What happens when dielectric is kept in the external electric field? The net, what happens? My question is that, what happens when a dipole is kept in an external electric field? The real impact is what? The net electric field will be reduced, and this very fact, this very term is used very importantly in the capacitor. Now dear students, let's talk about the capacitor. Dear students, what I have said, just that capacitor is what? A device which stores the electrical energy, or a device which stores the maximum charge in minimum area, right? What is the parameter that how a body can be given a charge? How much charge a body can be given? What maximum charge to a body can be loaded? What is the parameter which will decide that what charge a body can be given? Is there any parameter? Undoubtedly. That parameter is called to be the electric potential. Electric potential, you know, in my last video I have explained that. What is the potential? The nature of electric field intensity is the force, whereas the real nature of electric potential is the work. How will you define the electric potential? That it is the work done in bringing unit positive test charge from infinity to a point within the field. How will you define the electric potential? I used to say that the nature of electric field intensity is the force, whereas nature of electric potential is a work. Why? Let's discuss that. How will you define the electric potential? That it is defined as electric potential is the work done in bringing unit positive test charge from infinity to a point within the field. So you begin with the work done. It means electric potential has a nature of work. Now dear students, I have said just that capacitor is a method, is a way to store the maximum charge in minimum area, and how much charge a body can be given, that is defined by a parameter called electric potential that I have discussed visual at length, at very brief in my last few videos. Now look here, you say that capacitor is a what? That stores the maximum charge in minimum area. Let talk about a plate. This is a plate, right? This is a plate, a plain plate. I have to give you a charge to it, right? You have given the charge. Now, dear student, before going on this, one very important thing I'm trying to remind you. You know the method of charging. Method of charging is what? There is a three kind of method of charging. Charging by conduction, charging by induction, and charging by friction. In charging by friction, the two bodies are rubbed to each other and electron is transferred from one to other. Only electron is transferred, because proton and neutron we cannot talk about. Proton and neutron are the part of nucleus, and which electrons are transferred? In fact, most of the electrons transferred from the outermost orbit, right? Proton and neutron lies within the nucleus, so there is impossible to transfer the proton or neutron. Now, question is that how one gets the positive charge and how one gets the negative charge if only electron is transferred. Actually, when the electron goes to another body, transferred to another body, their negative charge increases. That is why that body which receives the electron will gain negative charge, whereas the body which loses the electron means the negative charge will be reduced, and so it gets the positive charge. Now, dear students, look here. What I was telling, that charging by induction, after in the friction you rub the two bodies. In the conduction, what happens? The two bodies which either both are charged or one will be charged and there is no charge on another one, that is neutral, and they are directly connected by a conducting wire. Then the charge will be transferred from one body to other body. And which factor will decide that from where to where charge will be transferred? If positive charge flows from higher potential to lower potential, positive charge flows from higher potential to lower potential. Negative charge flows from lower potential to higher potential. Positive charge flows from higher potential to lower potential, and negative charge flows from lower potential to higher potential. Right? Now, dear students, what happens that when you are using the method charging by induction, in that method what happens, you cannot charge a body permanently. Look here. And how you can make the permanent charge using method of induction? Look here. Here I have considered a positively charged sphere, right? It is a positively charged. And this one is a neutral sphere, right? And both are conducting sphere. Conducting sphere does not mean that it has already the charge, right? Conducting sphere it might have positive and negative charge, but total net charge is zero. Conducting means, right? Conducting doesn't mean that it has the charge. Conducting sphere means it has a capability to move the charge, right? Conducting sphere means it has a capability to move the charge, but it is not sure. You cannot say that it has the charge. Conducting sphere means it has a capacity to move the charge within it, right? Even in non-conducting case, it can have the charge, but it does not move from one place to other place in case of non-conducting material. Now look here. How a body can be charged permanently using method of induction. Now, dear students, this is a neutral sphere has brought close to the, but not in direct contact. If we have brought close to this, we have brought this neutral sphere close to the positively charged sphere, but the two spheres do not touch. They are close to each other. Then what happens? Because it is a conducting sphere, it has a number of free electrons. and these free electrons will be attracted by this one, and so let the free electron comes here. Because already before bringing this, it was neutral, so again it has to, because charge is conserved, charge follows the law of conservation. So whatever becomes here negative, the same becomes here positive. Dear student, what happens? If this one is removed, then again positive and negative will neutralize to each other and whole charge will finish. So how this charge can be made permanent? Now look here, again it was a positively charged sphere. You brought the neutral sphere. Neutral sphere doesn't mean that it does not have. Conducting sphere always has the negative charge, always has the free electron. The number of free electron ranges to 10 to the power 26 free electron per unit volume. That is why it is called to be the conducting sphere. Now, but actually what happens? In case of sodium, look here, sodium electronic configuration is 281. So this electron comes out. So sodium becomes positive one and one electron has came out. So total impact is 0, net charge is 0. In the similar way, the free electron comes out from the metal. Metal becomes positive and that electron will be compensated, and so net charge will be 0. Now dear student, look here, what my motive is to, what we have to do, we have to permanently charge this one. Now what I have done, I have grounded this one, right? If a body has been grounded, then you have not to think much about. If the body has been grounded, then this charge here, it has been grounded, which is consisting of positive charge. Grounded means whether it is a body has positive or negative charge, no matters. It has to finish at all. It has to vanish. If there is a positive charge, then what is means of ground? Then electron will travel from ground and will neutralize the charge. And if it has the negative charge, it will automatically flow to the ground. In both the cases, whether the body has positive or negative charge, no matter, it has to finish. If it is grounded, it has to vanish, it has to be perished if it is grounded. How it is grounded? If it is grounded, body is consisting of positive charge, then negative charge free electrons will flow from ground to this and will neutralize the positive charge in the body. But if it is consisting of negative charge, then these electrons will flow to the ground through the grounding wire. Okay, so now look here, if you grounded this one, now positive charge is finished. Now dear student, disconnect the ground and remove this one also. Now what happened? This negative charge was actually attracted by this positive charge. That is why it was the part of front surface. As soon as it is removed, that attractive force has been released, is 0. There is no attraction existing, and so this negative charge will be distributed uniformly on the surface of the body, right? So this is the method. This is the two spheres. I don't brought them into direct contact, but brought them close to each other, and this method of charging is called to be the charging by induction. That this is a method that how a body can be charged permanently using induction. Now let's talk capacitor. Capacitor, just I have told you, just we are talking about that it is a device which stores the maximum charge in minimum volume. Look here. Today I am taking just, this is a simple plate, right? We have to charge it, right? You will give the charge. Dear students, you know that which parameter decides that how much charge a body can be given. This is charging is directly proportional to the potential. If the charge increases, potential increases. As soon as you charge a body, its potential increases. And what should be the maximum charge? That depends on the potential. If you are giving continuously charge to a body, potential increases, and if this potential reaches to a level 3 into 10 to the power 6 volt, it is said to be the breakdown, right? Means you have given so much charge, right? You have given so much charge that the potential of this plate has reached to the 3 into 10 to the power 6 volt, and it is said to be breakdown. Means the plate has come to the breakdown. It means if more charge you will give it, the charge will be lived in air, right? In air you will see the lightning. So what maximum charge any body, whether it is sphere or whatever is, no matters, maximum charge, how much charge body can be given? A body can be charged until its potential becomes 3 into 10 to the power 6 volt. As soon as the potential level of the charging body reaches to the 3 into 10 to the power 6 volt, body, it is said that body has come to the breakdown, and if more charge it will be given, the charge will be leaked in air. So then now I have not applied any method. Simply our motive is, here is a plate and we have to charge it. Simply you will give the charge, right? And how will you give? You will give the charge. Potential will increase because Q is proportional to the V. Actually Q is proportional to the V. If you just remove this proportionality, it will multiply by a constant. This C is constant called capacitance, and C is equal to Q upon V. Q is a coulomb divided by volt, or this is coulomb per volt, or it is said to be the farad. The unit of capacitor is farad. I am technically discussing that what capacitor is. No, dear student, this is a plate. What I have said, that if you are giving charge, Q is proportional to potential, its potential increases, and when you have given so much charge that its potential came to this region, now next it cannot be charged. Now it means you have to apply a method that you give the charge but the potential does not reaches to this place, because once potential of the body reaches to this level, you cannot give the extra charge. So what you have to do, you will give every time you have to decrease the potential without decreasing. Capacitor is a device in which potential is decreased without decreasing the charge. How it is? Look here. What I have said, that this is a plate, right? This is our plate to which charge has to be given, right? It's a positive charge has been given. Now what I have done, I have brought another plate here. Dear students, what is, in fact, I have brought another plate here, right? This plate has not much role to play, but this plate is a method to reduce the potential without reducing the charge. Why we are using? Actually, it is not a part of capacitor. Capacitor is what? Capacitor is a method in which a maximum charge can be given to the minimum area. But if you have a single method, then nothing you can, no technology you can apply. So it is a technology, it is a technique to decrease the potential, and that is why you have to bring another plate, and as soon as you bring this plate, it will, because it is a positively charged plate, and so it will attain the negative charge because of induction. Because of this positive charge, look here, how potential is decreased. I have not decreased the charge at all. To this charge, I have not disturbed. There is no disturbance on this weight charge. What I have done, just I have said that it is not a part of capacitor. I don't mean to say that it is not a capacitor. Actually, the more important is this plate. And what we have to do, we have to decrease the potential without decreasing the charge. That is why I have brought this plate. And this plate, because of induction, has become negative. And so, because of positive charge, potential increases, and because of this negative charge, potential decreases. And what happens? Net potential is reduced. And when net potential goes below this level, now more charge can be given. Dear students, initially I have told you that capacitor is what? Capacitor is a method to give the maximum charge, maximum electrical energy in a minimum volume, right? So this was the plate. Our motive is to give the maximum charge to it. So you charged it. What maximum charge can be given to a body? A body can be charged until its potential reaches to this level. When potential reaches to this level, body comes into breakdown and charge. If further charge is given, our body is further charged, it will release the charge into air. The charge will leak, right? So this was a plate. If there is a one plate, nothing you can do. You will charge it. You will increase the charge, and ultimately it will come to the breakdown, and charge will begin to leak. Now, how you can give it more charge? So there is a method to give the more charge. I have brought a plate here, right? Now it is a positive charge. By the induction, it will attain the negative charge. Now, because of positive charge, potential increases, whereas because of negative charge, potential decreases. So, net potential level is decreased, and now you can increase the charge. You can further give the charge to this weight plate because its potential has been decreased because of presence of this negative charge, right? And so now more potential, more charge can be given, and this is the method of, this is a this is the theoretical interpretation that how charge can be given to the capacitor. Undoubtedly in the next video I will discuss the parallel plate capacitor, cylindrical capacitor, spherical capacitor, all are of the same type, and how their capacitance can be found, what is the capacitance of a simple capacitor, right? And then in the next video undoubtedly there will be series and parallel combination and other methods I will discuss. I am very sure and damn confident that you would be following my videos. You must be following my lectures. If there is a problem regarding to my lecture, please and please do comment, like, share my videos, subscribe my channel, so that you might be notified about my next video. Thank you.